Hi everyone, if you are preparing for IGCSE Computer Science 0478 Paper 2, this video series is designed to make your revision easier and more effective. We'll be covering chapter 7 to 10 using practice questions similar to those from past papers, so you can understand the type of questions you will face and how to answer them effectively. If you're also studying for paper 1, be sure to check out our separate video series on that, where we have covered past paper questions from chapter 1 to 6 in detail. These video series are here to support your learning, build your confidence, and help you achieve the best grade possible. Let's dive in and make your revision count. In this video, we are going to cover past paper questions on key topics such as program development lifecycle, flowcharts, structure diagrams, and test data. So let's get started. Topic 1. Program development lifecycle. State what is meant by program development lifecycle. A set of stages that are followed when developing a software solution. Helps structure the development process from planning to maintenance. Question 4. State three of the components part of a computer system. Number 1, input. Number 2, process. Number 3, output. Number 4, storage. Question 5. List 2 reasons why Smart EDU Limited should follow a program development lifecycle. Number 1. Ensure software is developed in a structured and organized way. Number 2. Helps meet users' requirements. Number 3. Makes it easier to identify and correct errors. And number 4. Improve quality and maintainability of the software. Question 6. Identify 4 stages of the program development lifecycle. Number 1, analysis. Number 2, design. Number 3, coding. And number 4, testing. Question 7. Identify and describe 3 stages of program development lifecycle. Number 1, analysis. Understanding what the program needs to do by gathering requirements. Number 2, design. Planning how the program will work and look before building it. Number 3, coding. Writing the actual instructions or code that computer will follow. And number 4, testing. Checking the program for errors to make sure it works correctly. Question 8. Tick one box to show which task is part of the analysis stage of the program development lifecycle. Option A, testing. Option B, coding. Option C, decomposition. And option D, design. So the correct answer is option C, decomposition. Question 9. Tick one box to identify the first stage of program development lifecycle. Option A, testing. Option B, analysis. Option C, coding. And option D, design. So the correct answer is option B, analysis. Question 10. 4 descriptions of stages in the program development life cycles are shown. Draw one line to link each description to its most appropriate program development life cycle stage. Not all program development life cycle stages will be used. Statement number 1. Develop an algorithm to solve the problem by using structure diagram, flowchart, or pseudocode. So that is design stage. Detect and fix the errors in the program. So that is testing stage. Identify the problem and its requirements. So that is analysis stage. Write and implement the instruction to solve a problem. So that's coding stage. Topic 2. Analysis stage. Question 12. State the purpose of analysis stage in the program development lifecycle. To understand and define the problem clearly, to gather and document user requirements, to identify what the system must do before designing begins. Question 13. Identify 3 different tasks in the analysis stage of the program development lifecycle. Number 1, gather requirements. Number 2, analyze user needs. And number 3, define system specification. Question 40. Describe 2 tasks carried out during the analysis stage. Number 1, gathering requirements from users or stakeholders through interview or questionnaire. Number 2, identifying inputs, processes, and outputs of the current or proposed system. Number 3, creating a requirements specification that lists what the software should do. Question 15. Explain what is meant by decomposition in the context of program development lifecycle. Breaking down a large, complex problem into smaller, more manageable parts. Each part can then be analyzed, designed, and developed independently. Question 16. Suggest how decomposition could help the team design the booking system more effectively. Allows the team to focus on individual components such as a user registration, appointment scheduling, and notifications. Makes it easier to assign tasks to different developers. Simplifies debugging and testing by isolating parts of the system. Question 17. Explain what is meant by abstraction in program development lifecycle. Removing unnecessary details to focus on essential features of a problem. Helps manage complexity by ignoring irrelevant information. Question 18. Discuss how both decomposition and abstraction contribute to effective problem solving in analysis stage. Decomposition breaks down a complex problem into smaller, easier parts to analyze and understand, while abstraction helps focus only on relevant details, ignoring complexity that is not important at that stage. Together, they reduce complexity, improve clarity, and allow better planning and design of the system. Topic 3. Design stage. Question 20. State the purpose of design stage in program development lifecycle. To plan how the system will work before it is implemented, to design algorithms, user interfaces, data structures, and overall system structure to ensure that all requirements identified during analysis stage are addressed. Question 21. Describe two design tools commonly used to plan the logic of a program. Number 1, pseudocode. It's a way of writing the step of an algorithm using structured English. Number 2, flowchart. It's a diagram that uses symbols to represent the flow of logic through a program. Number 3, structure diagram. It shows how a system is divided into modules or components. Structure diagrams. Question 23. Explain what a structure diagram is used for during the design stage. Number 1. It shows how a system is broken into smaller modules or components. Number 2. Helps visualize the overall structure and hierarchy of a program. Number 3. Makes it easier to understand how different parts of the program work together. Question 24. State 2 advantages of using a structure diagram when designing a large program. Number 1. Makes the system easier to manage by dividing into smaller parts. Number 2, helps with teamwork as different modules can be assigned to different developers. Number 3, makes the program easier to test and maintain. Question 25. Take one box in each row to identify if the statement about structure diagram is true or false. Statement 1. A structure diagram is a piece of code that is available through the structure of a program. So that is false. Structure diagram is not a piece of code, it's a diagram. Statement 2. A structure diagram shows the hierarchy of a system, so that is true. Statement 3. A structure diagram is another name of an array, so that is false. Statement 4. A structure diagram shows the relationship between the components of a system, so that is true. Question 26. A program asks the user to enter two numbers. The program then adds the numbers together and output the total. Draw a structure diagram for the program. To draw a structure diagram, first write the program name at the top. Then split it into three parts: input, process, and output. From the question, identify what the inputs are and place them under the input box. So we have two inputs. First one is num1 and second one is num2. Then do the same for process and output. So what is the process? Process is to add num1 and num2. So total equals to num1 plus num2. And what is the output? Output is to output the totals. So that's how you draw a structure diagram of any given program. Question 27. A satellite navigation system needs to ask the user to input their destination. It then finds the route to the destination and outputs the direction to the user. Draw a structure diagram for the system. Okay, so before drawing a structure diagram, let's find out the name of the system, input, process, and output from the given question. So the name of the system is satellite navigation system. Now let's find out the input. So the input is what? Input is the destination. Now let's find out the process that system will do. So that is to find the route. Okay. Now, the last thing we need is output. So what is the output of the system? Is the direction to the user. Okay, so now we have all the information. So now we can use that information to easily draw a structure diagram. So first of all, we write the name of the system or name of the app. Okay, and then we divide it into three parts: input, process, and output. So now we already know the input. What is the input? Input is the destination. Okay, and what is the process? Is to find the route, right? And what is the output? Output is the direction. Question 28. A login system is required. The system asks the user to enter their username and password. It checks if these are valid. If they are correct, the system outputs that they are correct. If they are incorrect, the system outputs that they are incorrect and prompts the user to re-enter their username and password. Draw a structure diagram for this login system. Let's do the same thing. We need to find out the name, input, process, and output. So what is the name of the system? So the name of the system is login system. Yep. So what are the inputs? So username and password. These are the two inputs from the user. Now let's find out what is the process. So process is to check if these inputs are valid or invalid. Then now let's find out the outputs. So the system will output two things. First, it will output correct. If the username and the password is correct, it will output correct and give the access. If they are incorrect, it will prompt the user that the login details are incorrect and ask them to re-enter. So these are the information now we know. So let's start drawing the structure diagram. So first of all, we need to add the name of the system, which is login. Then we need to add input, process, and output. So what are the inputs? So we have two inputs. Number one is username and second one is the password. Now let's talk about the process. So process is what? So first of all, the system will find the username and the password in the database. If it found those, then it compared the username and the password. So these are the two processes. Okay. So now let's find out the output. So we have two outputs. Number one is correct and number two is incorrect and re-enter. Flowcharts. Question 30. Explain what a flowchart is and how it is used in program design. A flowchart is a graphical representation of an algorithm using standard symbols. It shows the logical flow of a program from start to finish. helps programmer visualize the steps and decision point in a process. Question 31. Discuss how using pseudocode and flowcharts together can improve the quality of a program design. Pseudocode helps define the logic in written steps, while flowcharts provide a visual representation. Using both ensures clarity and reduces the chances of logical errors. Helps different team members understand and validate the algorithm more easily. Improves communication between designers and programmers. Question 32. The following 4 pseudocode statements and 3 flowchart symbols are shown. Draw a line from each pseudocode statement to the correct flowchart symbol that represents it. Okay, so now let's see the first statement. First statement says, if x greater than 12, so this is a decision statement, and we use the diamond symbol in the flowchart to represent the decision. Next statement is input x. In flowchart, we use this shape to represent inputs and outputs. Next one is x equal to y plus z. So now we are adding a variable y and z, and we are storing the sum of those two variables into a variable x. And so this is, we can call it a process, right? We're adding them and then we are assigning the value to the variable x. So for processes, we use this shape. Next, output, and as I told you that for the input and output, we use the same shape, so we'll connect this to here. Question 33. Draw the most appropriate flowchart symbol for each pseudocode statement. So first one is if number equal to 20. So that's a decision statement, and we know that for the decision statements, we use the diamond shape. Okay, so the next statement is number equal to number plus 1. So for this statement, we'll use this shape. Next one, print number. Print, output, input, we use the same shape. So for this statement, we'll use this shape. Question 34. What is the purpose of the following shape in flowchart? So this is the shape. Option A represents a subroutine. Option B represent a decision. Option C represent an input output. Option D represent a terminator. So this shape represent a subroutine. So option A is correct. Question 35. Describe the purpose of flow lines in a flowchart. Flowchart flow lines are used to show the direction of flow through the chart, which is usually but not always top to bottom and left to right. Question 36. Draw a flowchart to convert the length in feet to centimeter. Formula is length in feet multiplied by 30. So whenever we are drawing a flowchart, we start with this shape. This shape is called the start shape. Okay, start. Next, we need to ask a user to input the length in feet. Okay, so we use this shape for the input. Next, we need to use our formula to convert the length in feet to length in centimeter. So for that, we use this shape. LCN, length in centimeter, is equal to length in feet multiplied by 30. And next, we need to output the LCM. So which shape we use? We use the same shape, this one, okay, to output. And finally, we can stop our program by using the same shape. See, start shape and stop shape, they're same. Input shape and output shape, they're same. And we use this shape for the process. Question 37. Draw a flowchart to add 2 numbers entered by a user. So same thing. We start a flowchart with the start shape. Okay, then we ask the user to input 2 numbers. So which shape we use? We use this shape, and we ask the user to input number 1 and number 2. Next, we need to add those 2 numbers together. So which shape we use? We use the rectangle shape, number 1 plus number 2, and we're storing the sum of those 2 numbers into a variable total. Next, we need to output this total. So we use this shape, we use this shape. Okay, same shape, output total, and then we can finally stop the program. Question 38. Draw a flowchart to read 2 numerical values. Determine the largest of 2 values and output the largest value. Let's start a flowchart. Ask the user to input 2 values, value 1 and value 2. And next, we need to check, is the value 1 greater than value 2? So it's a decision. So for decision, we use the diamond shape. So is value 1 greater than value 2? We have 2 possible outcomes. First one is yes, and second one is no. In case of yes, we assign the value 1 to a variable max. In case of no, we assign the value 2 to variable max. So see, assignment is also used in this shape. It's a process shape, okay? Whenever you are assigning a value to a variable, it's also called a process. Next, we output the variable max, and finally, we can stop the program. Question 39. Draw a flowchart to represent an algorithm that reads a number and identifies whether the number is positive or negative. You should use standard flowchart symbols. Same thing, we start a flowchart with this symbol, start, then we need to ask a user to input the number. So we use this shape to ask a user to input the number. Next, we need to make a decision. We need to check if the number is less than 0. So we use the diamond shape to check this one. So we have 2 possible outcomes, yes and no. In case of yes, we output what? We output negative. In case of no, we output what? We output positive. And finally, we can stop the program. Question 40. Develop a flowchart based on the provided code. So this time we have a pseudocode, and we need to draw a flowchart based on the given pseudocode. So let's read the pseudocode. So we have line number 1. Number 1 says score equal to 75. And then we have line number 2. We have an if statement, and then we have an output statement. So we have only those 3 things in our flowchart. So let's start the flowchart. Same thing. We start the flowchart with the start shape. Then next, the first line is what? Score equal to 75. So that's the process. We are assigning a value to a variable. Okay. Next, if score greater than 50. So this is the if statement, right? We are making a decision. We have two possible outcomes, yes and no. Okay. So we use what? We use the diamond shape to represent this statement. So a score greater than 50. If it's yes, then we output what? We output pass. So since we don't have else statement, that's why there is no. And then we can simply stop the program. Question 41. Develop a flowchart based on the provided code. Let's look at the code. Mark equal to 60. If mark is greater than 50, then output pass, else output fail. Same thing, we start the flowchart with the start shape. The second thing we need to do is to assign the value of 60 to the variable mark. Then we need to make a decision. So we use a diamond shape. Is mark greater than 50? If yes, we output what? We output passed. If no, we output fail. And then finally, we can stop the program. Question 42, develop a flowchart based on the provided code. This time we have if statement and we have else if. Okay, so if within an if. So let's see how we draw a flowchart of this code. Start then when mark equal to 60. So this is the process. So mark equal to 60. Okay. Then if mark is greater than 80, if this is true, we output mark A. So same thing, we use the diamond. Is mark greater than 80? If it is yes, then we output what? We output mark A. But if it's false, we have another else if, right? Else if mark is greater than or equal to 60. So if no, we have to have another diamond shape to check is mark greater than or equal to 60. Okay. If it is true, we output mark C. If it's false, we output fail. And then we can finally stop the program. Question 43. An array called student is used to store the names of 20 students. The array is indexed from 0 to 19. The names of the students need to be output using a loop. There are different types of loop that can be used. A precondition loop tests the loop condition at the start of each iteration. Draw a flowchart to show how a precondition loop can be used to output the names of all students. So in this question, we need to draw a flowchart of precondition loop. So let's see how we can draw this one. We add the first shape, start shape, then we set a variable counter to 0, and then we need to use a decision shape to make a decision. So what is the decision? So is counter is less than 20. If this condition is true, we output the first element from the array student. Okay. And then we increment the counter by 1 for counter equal to counter plus 1. And then we go back. Okay. We go back and we continue this process until the value of counter becomes 20. And then once the value of counter becomes 20, we just simply stop the program. Question 44. An array called student stores name of 20 students. Use a post condition loop where the condition is checked after each iteration to output all the names. Draw a flowchart to show this process. The same thing, we just need to start the flowchart with the start shape, and then we need to set the counter variable to 0. Next, we need to output the name of the first student from the student array. Then we need to increment the counter variable by 1. And then we need to check the condition. Is counter less than 20? If yes, we go back. If no, we simply stop the program. Pseudocode. Question 46. Explain what pseudocode is and give one reason why it is useful in program design. Pseudocode is a method of writing algorithms using a structured but informal language. It is useful because it is easy to understand, language independent, and helps plan the program logic before coding. Question 47. Abstraction, decomposition, and structure diagrams are tools used during the program development lifecycle. Identify the stage of the program development lifecycle where they are used and describe what they are used for. Abstraction is used in analysis stage. It's the process of simplifying complex systems by focusing on the essential features and ignoring unnecessary details. Decomposition is also used in analysis stage. Decomposition is used to break down a complex problem or system into smaller, more manageable sub-problems or components. Structure diagram is used in design stage. It's a visual representation that illustrates the organization and relationship of different components within a system or program. Topic 4. Coding stage. Question 49. State what is meant by coding stage in the program development lifecycle. The stage where the program is written using programming language based on the design. It involves converting algorithm and logic into actual working code. Question 50. Describe what is meant by iterative development in the context of coding. It's a method of developing software in small steps or cycles. After each cycle, the code is tested and improved before moving on, allows feedback to be incorporated continuously into the development. Identify 2 types of errors that may occur during the coding stage: syntax errors, logic errors, runtime errors. Topic 5. Testing stage. Question 53. State the purpose of testing stage in the program development lifecycle: to ensure the program works correctly and meets the specified requirements, to identify and fix any errors before the software is released, to verify that input produces correct output. Question 54. Boundary data is one type of test data. Identify three other types of test data. Number 1, normal test data. Number 2, abnormal test data. Number 3, extreme test data. Question 55. Explain what is meant by normal test data and give an example. The data that is within the expected and valid range, used to test the program behaves correctly under typical conditions. Example, entering age as 25 in a system that accepts age from 1 to 120. Question 56. Explain what is meant by abnormal or erroneous test data and give an example. Data that is invalid or outside the acceptable input range, used to check if the program handles error correctly. Example, entering ABC for age when input should be a number. Question 57. Explain what is meant by extreme test data and give an example. Data that is valid but at the outer limits of acceptable input, used to test if the program works correctly at these limits. Example, entering age as 1 or 120 when the range is 1 to 120. Question 58. Explain what is meant by boundary test data and how it differs from extreme data. Boundary data tests the value of exactly on the edge of valid and invalid input ranges. It includes both just inside and just outside the valid range. Example, if the range is 1 to 100, boundary values would be 0, 1, 100 and 101. Difference. Extreme values are still valid, while boundary testing checks both valid and invalid edges. Question 59. Discuss the importance of using a range of different types of test data during the testing stage. Ensures the program works correctly with expected inputs. Checks the program's ability to handle errors or invalid input. Verifies performance at the limit of valid input and helps make the software more reliable and robust in the real-world use. Question 60. Identify 4 types of test data used in software testing. So number 1 is normal data, data that the program should accept. Then we have abnormal data, data the program should not accept. Then we have extreme data, data that is at the edge of what is allowed. And the last one is boundary data, data that is on the edge of being accepted and being rejected. Question 61. A program allows the user to enter 5 numbers between 1 to 5. Find normal, abnormal, boundary and extreme input values for the program. So the normal values are anything between 1 and 5. Extreme values are the start value and the end value. While the boundary data is what is the start value minus 1 and the end value plus 1. So we have 0 and 1 and 5 and 6 are our boundary data. Okay. And abnormal data, anything that is not between 1 and 5. Please take a screenshot of this diagram. This diagram will help you to remember how to find normal, extreme, boundary, and abnormal data. Question 62. A program allows the user to enter their age as a whole number between 10 and 100 years, inclusive. Give examples of the following types of test data for the program: normal test data, abnormal data, extreme data, and boundary data. So for this program, normal data could be any number between 10 and 100, inclusive, like 10, 20, 50, 100. Abnormal data, any data that is not a number between 10 to 100. For example, 9, minus 1, 11, 200, age 12.2. Extreme data, the largest number accepted, which is 100, and the smallest number accepted, which is 10. So these are the 2 extreme values for our program. Boundary data, either side of the largest bound, 100 and 101, and either side of the smallest bound, 9 and 10, are the boundary data. Question 63. A program asks the user to input numbers between 1 and 10, inclusive. Identify test data for this program. Normal test data, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Abnormal, anything less than 1 or greater than 10, or characters, strings, example, A, 2.5, minus 1, minus 8, 5, etc. Extreme, 1 and 10. Boundary data, 0 and 1, 10 and 11. Question 64. A user needs to enter a password that is at least 8 characters long. Provide an example of valid test data for this program. Normal test data, any set of 8 or more characters, but they must be text, have speech mark, for example, this and this. Abnormal, any set of characters with 7 or less characters. For example, this one, these are all abnormal values. Extreme, any with 8 characters only. For example, this one and this one could consider extreme test data for this program. Boundary, either side of 8 character bound, 7 character or 8 characters. For example, this, and this are example of boundary test data for this program. Question 65. Give the set of boundary data needed to check that a whole number is less than 50. So 49 inside the boundary and 50 outside the boundary. Question 66. A program checks that the data entered is between 1 and 100 inclusive. Identify one piece of normal, extreme, and erroneous test data for this program and give a reason for each. Normal test data, Test data example 50 allows any number between 1 and 100 inclusive. And the reason is data that is within the range and should be accepted. Extreme test data 101. Reason: data at the maximum, minimum end of the range and should be accepted. Error mess or abnormal test data example 300 allow anything that isn't between 1 and 100 inclusive, including other data types. Reason: data outside the range that should be rejected.